That is non-zero, no? I think time not there. Huh? Wait. I'll go for next question. Any other questions will take it. We'll do one thing. With respect to particle only, I think. Two particles A and B of masses 1 kg, 2 kg respectively are projected as shown in following diagram. Let's discuss some problems related to particles also. So we have here a system. So particle, so this is ball A and this is a ball B. Find the maximum height attained by center of mass of the system of particles from the initial position, center of mass of system. Okay, now this is A and B is there. So which is A? A is 1 kg, this is 2 kg. So somewhere center of mass should lie near to the heavier mass. And they are projected. So UB, this is UA. This is the initial position of center of mass by IC. He's asking to get the maximum height to which center of mass will ascend from the initial position of center of mass of system. This is initially center of mass is here. How to calculate? No? So directly take help of all the describe the motion of center of mass. Don't bother about the particles. So what is the acceleration of center of mass? Acceleration of center of mass should be equal to ma into A plus mb into ab by ma plus mb. What is mass of the particle? 1. So how g will act downward? No, minus g. Mass of the particle 2, g will act downward. So 1 plus 2. What is the acceleration of center of mass will be? Minus g. Will be downward, no? This is the acceleration of center of mass. Then what is the initial velocity of center of mass? UCM. UCM equal to M1 or say MA UA bar plus MB UB bar by MA plus MB. Anything directed upward, I'll take it positive. Anything directed upward, let me take positive. What is MA? MA is 1. Velocity is how much? 200. Plus MB is 2. This is minus 85 by 1 plus 2. So 15 meter per second. This is initial.
Sir, acceleration of B should be plus g, sir.
Y plus G?
Sir, it's downward, no, sir.
No, both are. Mg will act in the direction, no? Mg will act downward, no?
Yes, sir.
So VCM is 10 also.
VSM is how much?
10,
Anybody?
sir.
10, huh? I got positive. Okay, let it be 10 here now. This is the initial velocity of center of mass. Positive means it will be upward. So here, this is what? UCM. What will happen? We are not bothered particles. It's only about the center of mass is being asked here. So how to get this one? So somebody is asking, sir, it should be plus 2g. Okay, try to think. I'll also think.
I got it, sir. I got it, sir.
No, after this, what is the maximum height? with this one. So how to do that one? We know acceleration of center of mass, we know initial velocity. So what is the maximum height ascended by the center of mass? So any formula shall apply. Equations of motion means what is telling, the equations of motion what you earlier we were using, no, it can be also applied for the center of mass also. Not only for just any object, no, even for center of mass also you can apply equations of motion. Even center of mass accelerating, if varying with the time, you can take help of all that particular formulas what we earlier studied. So applying that, the height ascended by center of mass should be equal to UCM square by ACM. 2 ACM, H equal to U square by 2G. So 10 square by 2 into G it is 100 by 25 centimeter. From where? From initial. So initially at what height it is? Let's calculate. So this should be 2 into 90 plus 1 into 0 by 2 plus 1. So this will be 360 meter from the ground. So further what happened? It will ascend 5 meter. So what will happen to center of mass? It will just move by 5 centimeter and it will be here. So this will be the, so we should not bother. So you should not do like after some time A will be here, B will be here. So leave all the things, directly take help of center of mass. Just describe only the motion of center of mass. 5 meter. Sorry. When center of mass it has maximum height, where the particle A and B, they may ask you this also. So what is the time taken by center of mass to ascend to maximum height? So that also can calculate. T equal to UCM by ACM. Then with the help of that again you can manage, no? And when center of mass is at maximum height, where the B and A will be. Any of the things they can ask you. And now similarly, if I project two particles here now this concept you can extend like this. There's a ball A, I'll project with a speed U, another ball B, I'll project horizontally. Let this be theta. Then what is the trajectory of B? B will be like this. Then what about A? Let me take U1, U2, UB, UA. What about A? A will describe path like this, no? Now same concept, what all we studied projectile, no? We can apply the same ideas here. Now what is the question? Like what is the time taken by the center of mass to strike the ground? Then what is the maximum, the range, also at what horizontal distance the center of mass will strike it. So the ball B will come and strike, let's assume that one, it will come and strike the ground here, BB. The ball A, what will happen, will come and strike the ground here, BA. So where the center of mass you should expect, will it be here or should be between A and B or should be left side of B? Between A and B. The speed with which center of mass strike the ground. What is the path of trajectory of center of mass? So we can tell everything here, that one. So just we have to take help of the geometry. Everything you discuss now with respect to center of mass of system. So what is the initial velocity of center of mass? So UI, velocity of center of mass of system. This should be equal to UB plus UA cos theta I cap. Then along y-axis, it should be UA sine theta j cap. So what is the initial velocity of center of mass? UCX I cap, UCY j cap. So you know initial velocity of center of mass. Then what is the acceleration of center of mass? It should be minus g only. Now you discuss, don't bother A and B now. Look at only these and get all the things. So what is the height it will ascend? So What is the height it will ascend here? No. What is the time will take it? At t equals 0, they are projected simultaneously. So after what time they'll strike it? Different. So here
Sir,
minus h equal to just wait. UCy t minus AC t square by 2. Yeah.
sir,
Uh,
here UCX would be UB plus UA cos theta by 2, no, sir.
oh, masses. Huh? Okay, this one. Okay, some correction is there. In RE, I was writing how to masses are equal. If masses are different, okay, we'll do one thing. Masses, let it be different. So this should be MA UA cos theta, MB UB. Let me make masses different. Huh? It will give better picture for you. I cap, this should be 0 plus MB UA sin theta Okay, fine. I'm making things like this. Let's take masses different so that you'll get a better picture. They can ask you how to calculate initial velocity of center of mass. There's a method.
So shouldn't that be MA UA sin theta?
MA symbols. MA UA sin theta J cap MA plus MB. We assumed all things. Fine. Okay, this is about the now what will happen? Initial velocity of center of mass should be like this. Everything you should use velocity to calculate initial velocity of center of mass. If masses are equal, then by 2 you write it. Masses are equal. Then how to calculate acceleration of center of mass? Again, the method is same. Minus MAG. So here acceleration of center of mass, what you're going to write it here? AC is equal to MA minus G, J cap. Now get the acceleration of center. Now you discuss everything, the motion with respect to this. So minus H is equal to UCY T plus ACY T square by 2. Similar to projectile motion, after what time the center of mass will strike the ground. So when center of mass striking ground, what happens to A and B? You have to verify. When A is striking, where center of mass will be? When B is striking the ground, where center of mass will be? Anything they can ask, and you can show that trajectory. Somewhere the center of mass will move. When B is striking, where center of mass will be at what height or what is the position. So any of the questions can be asked there. You have to just go back to projectile motion. And how to calculate that initial velocity of center of mass, or the height ascended, also what is the time, that one. Calculate initial velocity of center of mass, calculate acceleration of center of mass, once you know that, and bring equations of motion. So I think now it's a very generalized, they can ask you best of best questions here. Okay, fine. So tomorrow I'll start with the conservation of linear momentum. Already I introduced here. Tomorrow we'll exclusively focus on that. And day after tomorrow we'll just mix up all the problems, center of mass, nothing to do. Now where any problem comes, if anything displacement, we'll go for center of mass. Anything velocity of system, we have to go for conservation of linear momentum. Are you getting no? If they ask you something displacement, take help of center of mass. If they ask you something, the velocity or the speed of the objects in a system, go for conservation of linear momentum. Check net force 0, non-zero. Both are combined. If you think about displacement, center of mass idea will come. If you think about the velocity of the systems, then momentum will come. So I feel both are same. The problem, what you're doing for center of mass can also be converted to the momentum problems. So try to analyze this. This difference is what you should notice here. So all the conservation of linear momentum problems, you can convert that into center of mass. All center of mass problems, you can convert that into conservation of linear momentum.